Rational equations. So we're finally getting to the equations part of this unit. We've done all these expressions, now we have to put it together and solve some equations. So the basic idea, I have all the steps kind of stepped out here. So we're going to go through all of them with this particular problem, just so you can follow what you're supposed to do, or, you know, a possible way to solve these, I guess. There's many. First thing I like to do is make all terms fractions. So if we're looking at this first example here, one sec. It was no one exciting. Okay, make all terms fractions. So looking down here, this doesn't look like a fraction, and neither does this one. So I like to make them all fractions first. So I can look at and it's obvious what the denominators are, because that kind of is the key to this whole thing. If I have to subtract, keep, change, change. Now some of you don't like doing that, and that's fine. I have to, or I lose my negatives. So that's all. That's the only reason. It's up to you. Okay, down here I have an x. So what I need to do is I need to get all of them. Okay, so we just did this. We keep, change, change. We want to find a common denominator. That's what we're up to now. So what we're doing is we're looking, okay, and it's the same deal as when we were adding and subtracting. We look at them. Okay, this one has an x. This one doesn't, so it needs one. And same deal with that. And that's what you want to go for. What factors are my terms missing? And you multiply. Remember, you got to do whatever you do to the top, you got to do to the bottom to change your fractions. It's basically you're unreducing them. So I'm left with x squared over x plus negative 14 over x equals 5x over x. Now these are all the same. This is an equation. I just got all these to be equal. Because this is an equation, I can be like, well, if all those are equal, I don't really care about them. What I care about is the part that isn't equal yet. Okay, so we cancel those out. We did that. When all the denominators are the same, eliminate the denominator. So that's what we did. Okay, because it is an equation, they're all the same, so they can go. Now I'm going to solve this equation now. It's a quadratic, so remember, get everything equal to 0 in a quadratic. Anything that isn't linear needs to be set equal to 0. So we get x equals 7 and x equals negative 2. Okay, the last thing you want to do is make sure it's check for extraneous roots. So that just means I look at my original equation. If I could erase, I would. I don't think I can. Ooh, I can erase some of it. You look at your original equation. The only denominator that has an x in it is that one. If I were to plug 7 in, what would that be? Well, that would be 7. Okay, if I plug negative 2 in, I would get negative 2. So as long as that isn't 0, remember the place that makes a fraction undefined, when the denom is 0. None of these two answers make that denominator 0, so 7 and negative 2 are my answers. Done. Sorry, moving on. So here, same idea. Now this is the one that we did like yesterday, that was, or whatever, weekend it may have been. So here we go. Make everything a fraction. So 2 isn't a fraction, so I'm going to put it over 1 to make it so. This is a subtraction problem, so I'm going to make this positive and make it a negative 2. Okay, again, it just makes my life easier. Now we have to look for factors that are missing. This is the one that blows our mind because they're so close. One has an x, the other one has an x, but they're not even close. This whole thing is a factor. I can't multiply this one by anything to get it there. So what I have to do is multiply. The common denominator is x plus 1. That's my common denominator. I have to multiply these two together. So this one is missing the x. Okay, it has the x plus 1, it doesn't have the x. This one here has the x, but it doesn't have the x plus 1. Oh, I'm writing with an eraser. Nice. And unfortunately, this one here needs them both. So me and my awesome editing, put this one here. So that multiplies times the -2, and the bottom is x times x plus 1. So I'm going to write this out so you can see it. You don't necessarily have to, but so this one is 3 times x plus 1 over the denominator plus a -2x times x plus 1. This is always an issue. Multiply the -2 times the x first, and then we're going to distribute it through. I don't know why it is. It just always is. Equals -2x squared. I didn't distribute that through at this moment because I just didn't feel like it. Now all the denominators are the same here, so I'm going to get rid of them. Now this only works in an equation. Are you listening? Only in equations. Okay, if we're simply adding or subtracting, we have to leave our denominators. We can't change a 2 over 5 to just 2. That just doesn't make sense. Okay, but since this is an equation, that's why this works. So now I'm left with the top. I'm going to distribute in as I go. So 3x plus 3. Now I'm going to distribute that -2. So it's -2x squared minus 2x equals -2x squared. Well, this is handy. I'm solving this guy. These are exactly the same here. Those go away. Combine my like terms. I'm left with x plus 3 equals 0. Don't let this freak you out. We do this all the time. So I combine these two like terms. I got x. Okay, so solve. X equals -3. Then we have to go back. The two denominators are x plus 1. And the other one is x, right? These are our denominators from the beginning problem. We want to plug in that -3. So I'm going to plug in -3 plus 1. That's -2. And I'm going to plug in -3 here. That's -3. Neither one of these are 0. Okay, so this is a good, I checked. That's my check. I have to take these numbers, whatever I get for an answer, and plug them back into that. Okay, then we have this two super fancy problems. I realize the time is running short, but we just need to go through these really quick. I'm going to help you find the common denominator here and then ask you to solve this. So our common denominator, hopefully you realize that this is an opposite factor. 3 is positive, then these two. Okay, those two are exactly the same already. Okay, so what I need to do is just make this one right here the same as that. And the only way I do that is I multiply it by -1. So our common denominator is x minus 3. To get this one here to be x minus 3, I simply multiply it by -1. So rewriting this one is x over x minus 3. I'm going to do my keep change here. So remember, make this plus, distribute that negative through. So when I do that, I get a positive -x minus 1. And when I distribute this negative through here, the x becomes positive, the 3 becomes negative, and the 5 up at the top is positive. Denominators go away. X minus 1 equals 5. I don't know what happens. I just don't know what to do. Okay, as long as I didn't mess up, because you know me, I tend to be like that. Remember what happens here? The two numbers are different, so that means no solution. And then finally, this particular one, maybe some of you realize if you look at it, you could simply give them both. You know, this one I could give it an x minus 1, and this one I can give it an x plus 5, because these are the factors. But that's exactly the same as cross multiplying. But just so you realize, the common denominator here is x plus 5 and x minus 1. Denominators go away, and then I have to do the box method, double distribute, whatever your feelings. Take a second and do those and see what happens when you solve it. Okay, so you gotta do the box method or whatever you gotta do for those. Okay, you should have gotten this when you multiplied, as long as I multiplied right. However you did it, these two are the same, so when I subtract them, they do go away. So I'm left with 17x plus 10 equals 7x minus 10, and we simply solve. So it's 10x. I'm going to subtract 10 here. In the same line, because that's what I want to do, divide by 10, and I get x equals negative 2. So I check it. The two denominators were x minus 1 and x plus 5. I'm going to plug x equals negative 2 in there. When I do, I get negative 2 minus 1, which is negative 3. That one's okay. And this one, I get negative 2 plus 5, and I get a positive 3. That's okay. As long as it's not 0, we're good. All right, have a good day.